Explaining question number 2 in this video. So let's look at first question number 2. So it is given that A is a Poisson process with parameter lambda, and where the number of random points arrived in t1 comma t2 equals to k is given by this Poisson distribution, and xt is a stochastic process where it is defined as equals to 1 if n is odd in 0 to t, and is minus 1 if n is even in 0 to t. So we need to find out the probability of xt equals to 1. Also we need to find out the expectation of xt and the autocorrelation of t1 comma t2, and whether we need to find out whether xt is a wide sense stationary process or not. So let's look at the solution. The solution is pretty simple. We find that expectation of xt equals to 1 only when number of points arrived in 0 to t is odd, that is given here. So we take summation over all the odd points. So k goes from 1, 3, 5 to 7, all the odd points, and we just do the Taylor series explanation of e to the x. So that is e to the power lambda t equals to 1 plus lambda t plus x square by 2 factorial plus x cubed by 3 factorial, and also e to the minus x equals to 1 minus x plus x square by 2 factorial minus x cubed by 3 factorial. So we take the we subtract subtract e to the we subtract e to the power minus lambda t from e to the power lambda t, and so we get that summation of lambda t to the k by k factorial is equals to e to the lambda t minus e to the minus lambda t whole upon 2. So after some calculation, probability of xt equals to 1 can be written in this form, that is 1 minus e to the minus 2 lambda t whole divided by 2. So now the next question was to find out the expectation of xt. So expectation of xt is nothing but the value into probability of for all the points. So we know over all the odd points value of xt is 1. So this is multiplied by 1. I omitted that. And this is over all the even points. This is multiplied by minus 1. So the minus sign comes here. And we take the summation over all the even points, and here we take the summation over all the odd points. And when we simplify the summation form, we see that this is nothing but the expansion of e to the power minus t. So this is e to the power minus t into minus of e to the power minus t. So we take the multiplication, and that comes up to a minus of e to the power minus 2 lambda t. So that's the expectation of t. Now we need to find out the autocorrelation of our t1 comma t2 to find out that whether they are what was it is WSS or not. So let's look at the solution. So RT1 comma T2 can be written as expectation of XT1 into XT2. So XT2 can be actually broken down into two parts, XT2 minus XT1 plus XT1. So we multiply XT1 with XT2 minus XT1 and XT1 square. So it comes out that XT1, and so it comes out that T1 and T2 minus T1 are Poisson process, and also they are non-overlapping. So that means they are independent. So we can take the independence criteria and multiply them together. So that it comes out to be expectation of expectation of xt1 into expectation of xt2 minus xt1 plus x square of t1. So what is expectation of x square of t1? That is nothing but summation over all the points, because x can take two values, 1 or minus 1. So when we are squaring minus 1 plus 1, both becomes plus 1. So we take the summation over all the points, and this comes out to be 1. So now from equation 1, now from this equation we get, after some manipulation we put the values of expectation of t2 and expectation of t1, and after some manipulation we get that rt1 comma t2 is e to the power 2 lambda into t1 plus t2 minus e to the power minus 4 lambda t1 plus 1. So as we see, autocorrelation of t1 t2 doesn't depend on t2 minus t1 only, and also the expectation of this process is dependent on t. This is not a constant, so xt cannot be said as a wide sense stationary process. So that's it for question 2. Thank you.